Right. So now please try to understand, we represent a vector quantity by a directed line segment. Basically, what a vector
Sir,
is. Yeah. Ramesh,
Sridhar sir.
screen sharing జరుగుతుందా? రమేష్, స్క్రీన్ షేరింగ్ జరుగుతుందా?
Sir, voice loud. Okay, sir.
Right. Okay. Now, you can see that vector is a physical quantity which will have both direction and magnitude. For example, I am suspending a block from the roof. Like this. This is the block. Now, this block is, say, of 5 kg mass. You know, what I will be doing right now is I will represent the weight mg by a directed line segment like this, mg. Remember, it has a starting point and ending point is with a head, arrow head. Like, for example, OA. Here, OA is a directed line segment. Okay. And this directed line segment length is proportional to magnitude. And arrow indicates the direction of the quantity. Okay. So this is how you will represent a vector. For example, I'll give you another case. For example, an object is moving in a circular path like this. The object is somewhere over here at this point. Now, at this point, instantaneous velocity will be like this. Its instantaneous velocity will be like this. Okay. So here, the object which is moving in a circle of some radius r is having some instantaneous velocity like this. So I will represent v bar with a directed line segment OA like this. So you represent a vector quantity by a directed line segment. Fine. Now, again, we require one more understanding. We represent a vector in a manner like this, A bar. You are representing a vector like this, A bar. In this, magnitude of A, this is called magnitude of A. And in fact, this is vector A. They are different. Similarly, there is another thing, A cap. This is called unit vector along A bar. So therefore, A cap is defined as A bar by magnitude of A bar. See, we have a standard representation of vector in different directions. I'll give you one example for this. Remember, I'm giving a backup class of vectors. For example, in our Cartesian coordinate system, say this is x-axis and this is y-axis. So now I am representing the force experienced by a block. One of the force experienced by the block, which in turn is represented by F bar. Remember, standard representation of a unit vector in the x direction is I cap. Standard, in some books, they will also give as x cap also. In some foreign editions, they will give it as x cap. Along y, you will represent it as j cap or y cap. No issues. So with x-axis, this force vector makes an angle theta. Now you represent this vector by a directed line segment OA. Now what is that you need to do right now is you draw a projection from A onto x-axis. Okay, this is a projection onto x-axis. Now this will meet x-axis at a point some m. Similarly, you draw a projection from A onto y-axis. Okay, this will intercept y-axis at point n. The geometry says that OM is OA cos theta according to trigonometry. Similarly, ON is the same as MA is the same as OA sin theta. I am just taking it right angle triangle properties from trigonometry. In fact, OM is called x component of F bar. In fact, ON is called y component of F bar. Carefully study these terminologies. So therefore, instead, you can write hereafter OA bar as OM I cap plus ON j cap. This is called resolving a vector into components. This is called resolving a vector into components. So therefore, finally, you can write F bar as F cos theta I cap, F sin theta j cap. This is how you will resolve. Earlier, in projectiles, same U you have represented as U cos theta I cap plus U sin theta j cap. Same I am doing that for F. Right. So I have introduced what a vector is. I have introduced what a unit vector is, and I have introduced how to resolve a vector. Now the deal is with addition of vectors. See, again, I am not deriving the total. This is a backup class. Okay. The addition of vectors. See, for addition of vectors, if it is two vectors, you will use either triangle or parallelogram law of vectors. First, let us deal parallelogram law of vectors. Parallelogram law of vectors. In parallelogram law of vectors, for example, there is an object like this. This object is simultaneously experiencing two forces simultaneously at a time. So you can't say what is the sum of the vectors. Don't use the word sum of vectors. You should say the resultant of the vectors. For scalars, you will say simply sum it up. For example, I went to a shop, purchased 5 kgs of rice, 1 kg of dal, half kg of ghee, 1 kg of oil, groundnut oil, and half kg of sugar and quarter kg of tea powder, all that. Now, then I will say, Arey, submit up the bill. What is the total bill? What is the total mass of the content? But never say for vectors that sum it up. You should say resultant. Here in this case, you have two vectors which are subtending an angle of theta with each other. Now, you want the resultant of these two vectors. For this purpose, what I would like to suggest is, what parallelogram law suggests is, so you represent these two vectors by the two adjacent sides of a parallelogram drawn from same point. See, the two adjacent sides are from A, originating from A. Now you complete the parallelogram. How to complete the parallelogram? You draw a line OA, a parallel, extend or replicate a line whose length is same as OA parallel to OA. Let that be C. So BC length, OA length same. OA bar direction, BC bar direction same. Then you can say they are equal vectors. Similarly, you draw another line like this, AC, which is parallel to OB. So OB direction, AC direction same. OB magnitude, AC magnitude same. Right. Now what do you want? The resultant is represented by the diagonal drawn from the same point. Remember, F1, F2 from originated from O. Even the resultant is also originated from O. And this is called resultant vector F bar. And let this makes an angle phi. Now, for example, you extend this vector like this. Extend this. Similarly, extend or draw projection of C onto this line. Let it meet at point D. Don't forget, this is also theta because OB, AC are parallel. Now, what you want is the length of OC. Right. Now, you see, you can, from this, I can say that I can have a right angle triangle. I have a right angled triangle. Okay. Which is ODC. Right. Now, also I have another right angle triangle ADC. Please don't forget, wherever AD is available, I can write AC cos theta. AC is nothing but F2 magnitude cos theta. Wherever I have CD, I can write AC sin theta. Don't forget, AC is nothing but, I think I've done, right, F2 sin theta. I hope there is no doubt till this point. Now you have in the original triangle which I have chosen here, over here, we have OC square is equal to OD square plus DC square, which is nothing but OD is nothing but OA plus AD square plus DC square, which is nothing but OA is F1, AD is F2 cos theta, whole square plus DC is F2 sin theta. Right. So finally, I have OC square like this. OC square is nothing but F square. F1 square plus F2 square cos square theta plus Okay, you have 2f1 f2 cos theta plus f2 square sin square theta, which is nothing but f1 square plus, Ariyar, please try to understand, you have f2 cos square theta, f2 square sin square theta, the sum of which gives you f2 square. Because sin square theta plus cos square theta is equal to 1. And this is 2f1 f2 cos theta. And this is f square. Now I have given you clearly about some information on resultant. So finally, f is f1 square plus f2 square plus 2f1 f2 cos theta. So I have given you the magnitude of the resultant. But not only that, in this triangle, you know the angle is phi. In that right angle triangle. Okay. Now, what you can do is that tan phi from there. I'll change the color. So tan phi is equal to opposite side by adjacent side. CD by OD. CD by OD is again OA plus AD. Now you have all that available. CD is nothing but F2 sin theta. Right. OA F1 plus F2 cos theta. Remember, now I have given you direction. Here you have magnitude. So I have given you the magnitude of a resultant and the direction of the resultant vector. Here I have applied parallelogram law of vectors. See, I am repeating you again. I am not teaching the vectors. I am just giving you a backup part. Right. Next, that is parallelogram law of vectors. Right. I hope there is no doubt till this point, but I just want someone to respond on behalf of your class. So is it possible? Anyone? Anika, take a responsibility otherwise. Right. Next. I'll go with triangle law of vectors. So I'll go with triangle law of vectors. This is a very simple logic. Now you see, same situation. For example, a body is simultaneously acted upon by two forces. One is F1 bar, the other is F2 bar, as same as the previous situation. And that makes an angle theta with each other. Now, right now what I am going to do is, see, unlike in the previous case, what I would like to do right now is, I will now represent these two sides differently. How? Now I will represent F1 bar, okay, with one side of a triangle OA bar. Now, exactly this side I am drawing here. Remember, I am drawing the triangle in order. OA, AB. That is the order. Tail to head, tail to head, tail, head, tail, head. Now the third side, closing side, taken in reverse order, gives you the resultant. This is a triangle of vectors. Remember here, you will take up this angle as theta. You will take up this angle as theta. And this one will become 180 minus theta. Right. Remember, there are some simple geometry rules that you need to know. I'll just give you that. For example, there is some triangle like this. This triangle is having side A, side B, side C. This angle, Anika, anything which you would like to discuss? No, right. Very good. Thank you, Anika. A opposite angle is theta 1. B opposite angle is theta 2. C opposite angle is theta 3. Then what is the sine rule in mathematics? Sine rule. You will have A by sine theta 1 is equal to B by sine theta 2 is equal to C by sine theta 3. That is the sine rule. This is sine rule. So we will oftenly use this rule repeatedly in our future course. Similarly, we have one more rule, the cosine rule. What is your cosine rule? For example, under similar conditions, same situation, cosine rule says that is all mathematics basics. Cosine rule states that, for example, you have selected here AB. Selected here, for example, AB, something like this. Opposite to A, you have theta 1, right? In this case, you will write A square as B square plus C square minus 2BC. What is the angle opposite to A? Theta 1. Cos theta 1. This is cosine rule. Sir, why you are teaching that right now? I will apply cosine rule here. In this triangle, one is F1 side, F side, the other is F2 side, the other is F1 side. So here what I can write using cosine rule? Clearly, F square is F1 square plus F2 square minus 2F1 F2 cos 180 minus theta. My dear friends, this will nothing but F square is F1 square plus F2 square plus 2F1 F2 cos theta. That's the deal. Any doubt till this point? So to add two vectors, either I will use a parallelogram law of vector basics or triangle law of vector basics. And meanwhile, I might use any of these two rules repeatedly. Just keep that in your mind. Now, if A bar is a vector, B bar is a vector, C bar is a vector such that their sum is zero resultant, then how I will represent ABC bar? I will represent ABC bar as three closed sides of a triangle. Three closed sides of a triangle. A bar, B bar, C bar. So you can represent these three sides with the three adjacent sides of a triangle. Three adjacent sides of a triangle. Taken in order. That's it. And if it is more than three sides, we will use polygon law of vector. That I will discuss later. Right. So you are saying that if this is A bar, one vector, and if this is B bar, another vector, you are representing A bar plus B bar by this diagonal. Now, what about A bar minus B bar? How to define A bar minus B bar? Simple. Now, A bar minus B bar is what you want. What is minus B bar? Magnitude same as B bar, exactly opposite in direction. Which means now you require resultant of these two vectors. So the resultant of these two vectors will be nothing but A bar minus B bar. So what is the expression for the magnitude of A bar minus B bar? I am assuming the angle between AB is theta. A bar minus B bar magnitude is simply A square plus B square minus 2AB cos theta. That's it. Whereas A bar plus B bar magnitude already you know. A square plus B square plus 2AB cos theta. That's the deal. Okay. That is a clear-cut idea. Next. So sum and difference I have done. Now products. Remember, all these are basics. Basics in the sense, the brush up part which I am doing for my upcoming classes. Now dot product or scalar product. The output is a scalar quantity. So how it is defined? For example, you have a vector like this, A bar. You have another vector like this, B bar, and that makes an angle theta. Now, A bar dot B bar is defined as A into B into cos theta. Means, for example, component of B along A, if it is B cos theta times A gives A bar dot B bar. Otherwise, if you want component of B along A bar direction, simply do this. A bar dot B bar by A. Therefore, component of a vector is always a scalar quantity. This is how we will define a dot product. For example, work is defined as dot product of force and displacement. Power is defined as dot product of force and velocity. Kinetic energy is defined as half m v bar dot v bar. Likewise, we have some examples. Remember, all the outputs are scalar quantities only. It will have some number. It won't have direction. It can be positive, 0, or negative. Anything is possible. If theta lies between 0 to 90, then dot product is positive. If theta is equal to 90, dot product is 0. If theta is greater than 90, between 90 to 180, remember, between any two vectors, the minimum angle is 0, the maximum angle is 180. It can't be more than 180. Which means in this case, dot product is negative. Okay? Remember our fundamental dot products. I cap dot I cap. Wherever you see, you write it as 1. Why? I cap dot I cap is 1 into cos 0. 1 into cos 0. So 1. Similarly, j cap dot j cap is 1. K cap dot k cap is 1. On the other hand, I cap dot j cap is 0. Why? Because cos 90, 0. Similarly, j cap dot k cap is 0. K cap dot I cap is 0. Also remember, A bar dot B bar is the same as B bar dot A bar. There is no difference. It obeys commutative rule. No difference. It is the same quantity. So I've just given you about dot product and the significance of dot product. Now, someone please give me clarity. Anika, please give me clarity whether our students followed this or not. Just give me some clarity. Someone please give me clarity on this. Post the message if there is any doubt. It's clear, we have understood. Thank you. Now, in this case, dot product is not returning any vector quantity. Right. So sometimes the product of vector also gives a vector. Sometimes it happens. Product of vector gives another vector. And such a case is called cross product or vector product. Such a case is called cross product or vector product. Remember, you require some convention to understand this situation. I'll explain clearly. For example, I am representing A bar like this and B bar like this. Say A bar and B bar lies in a plane. In a plane. Both the vectors lies in this plane. A bar and B bar is in this plane. The cross product of A bar and B bar is defined like this. Let it be a vector called C bar. Remember, the vector is perpendicular to the plane containing A bar and B bar, such that C bar is defined as A bar cross B bar, and magnitude of C bar is defined as A into B into sine theta. A into B into sine theta. Remember here, C bar is perpendicular to plane containing A bar and B bar. So how to represent or how to demonstrate the direction of this? It is the best thing what you can do is right hand grip rule. Right hand grip rule. What is right hand grip rule? I'll just show you the diagram. Different are there, right hand corkscrew rule, something like that. But still, I am taking up this diagram. Follow carefully. This diagram. Right. Now, first, you take the right hand palm for a shake hand mode. Set it along A bar direction. Turn the four fingers towards the B bar direction. This is A bar and this is B bar direction. Right. Then the thumb represents the direction of C bar. If here theta represents the angle between A and B. This is how dot product is defined. Cross product is defined. Output is also a vector given by the direction right hand thumb. I repeat, set the four fingers of right hand first for the shake hand mode. Set the four fingers in the direction of A bar. Turn the four fingers towards B bar. Now the thumb, which is erect vertically up, that represents the direction of C bar. Okay. Now it is very clear from this picture. I can confidently say that from this very particular picture, you can understand the direction of C bar. See, remember I cap cross J cap will be K cap. Yes, X axis, Y axis, Z axis. Similarly, K cap cross J cap is I cap. That should be the order. J cap cross K cap is K cap cross I cap cross J cap K cap. K cap cross I cap is J cap. And okay, next J cap cross K cap is I cap. That's the order. For example, if you are taking this one as I cap direction and this one as J cap direction, this will become K cap. Now you similarly set four fingers along K cap direction. Now all the four fingers are along C bar, for example. Turn that towards A bar. K cap cross I cap. The thumb is towards J cap. Similarly, now you set the four fingers in which direction? Like in that along the direction of J cap. And turn towards C cap. Our thumb is directed towards I cap direction. Likewise, you can set. But on the other hand, you change anything in this, you will meet with a negative result. For example, in this case, if you do J cap cross I cap, you need to write minus K cap. If you write I cap cross K cap, you need to write minus J cap. If you are writing as a K cap cross J cap, you need to mention it as minus I cap. Why I will explain. In the same, it is A bar cross B bar. Suppose if you want B bar cross A bar, your thumb need to be downwards. You should flip the diagram, no? The thumb needs to be downwards. B bar cross A bar. So A bar cross B bar is not equal to B bar cross A bar because direction is different. Even though magnitude is the same, direction is different. So that should be taken care. This is the introduction to cross product. See, torque is, for example, torque is defined as, all this we will discuss again leisurely in rotation. I'm just giving an example. R bar cross F bar. Similarly, angular momentum is also an example for cross product, which is given by R bar cross MV bar. They are examples. See, I will use a cross product like this. For example, say I want A sin theta component anytime. You have A bar, B bar, two vectors like this. You have A bar and you have B bar. Now you have that this angle is a theta. Now you have drawn a perpendicular onto here. You have drawn a perpendicular onto here from this tip. From this tip. That is a perpendicular drawn like this. So if you want the magnitude of this is nothing but actually A sin theta, geometry wise. This is nothing but magnitude of A bar cross B bar by simply B. Previously, projection I have given. Component, B bar component along A, how to determine I have given. Now A bar opposite component, if you want, you can use this. So this is all basics of vectors. See, I've just given basics only. I didn't even went into any sort of depth, just introduced. Why? Because for relative motion part, I require all this stuff. Don't forget, before the closing of the class itself, I'll post these notes. Don't worry. I'll post these notes before the ending of the class itself. Once I post this, only then I'll say I've done and I'll close the class. Right. Now, dot product is done, cross product is done, sum is done, difference is done. Now we will step into relative motion in 2 dimensions. Now we will move on to relative motion in 2 dimensions. Relative motion in 2 dimensions. Right. Already I taught you relative motion in 1 dimension last week. See, for example, I'll just give you some idea. This is some stationary house which remains at rest on the ground. Rest. Right. Now imagine a situation like this. An object A is moving in this direction. At some instant, A is here with A moving in this direction with a velocity VA bar. This is as observed by an observer who is sitting in this house. There is another observer who is moving in this direction in this direction, this observer B is moving in this direction like this. This is a VB bar. All these observations are with respect to an observer at rest. Now imagine that I am going to see this entire world This is all what we have. This is with respect to, this is with respect to ground. The picture what you are seeing is with respect to ground. Now I am going to repeat the same situation, same observation. House is here. I am observing the entire world in a frame attached to A. I am now a frame attached to A. For me, A is a rest. Such an observation is called relative. Now tell me what is A observing in his world. In his world, A will observe the house is moving in a direction exactly opposite to his velocity. In fact, the house is nowhere moving, house is at rest. But since A is moving, with respect to A observes that the house is moving with a velocity minus a VA bar. Similarly, already you observed that P is having some velocity like this. B is having some velocity like this. VB bar. This is B. Jobs observed by an observer on the ground. But with respect to A, the same thing is going to be is having some minus VA bar velocity. At a time, B experiences two velocity with respect to A. Remember, the entire picture which I am drawing is with respect to A. Now, at a time, two velocities. Suppose this is theta, this will be going to be theta. 90 minus theta, in fact. Right. Now, what is going to happen is, this one will become relative velocity of this one, this vector will represent this one represents velocity of B with respect to A. In fact, A see that B is actually moving in this direction. So this dotted line, direction of motion of B with respect to A. Okay? So therefore, see the difference. Left hand side, we see B is going straight downwards. Whereas with respect to A, B is moving in a different direction. And this is defined as vector sum of these two. VB bar plus minus VA bar. Finally, velocity of B with respect to A is defined as VB bar minus VA bar. This is how you will define relative velocity in 2 dimensions. Asking you again, do you have any doubts? Confirm. Asking you again, do you have any doubts? No doubts. Right. Thank you. Now, I am going to discuss something related to the same right now. Okay? This is the introduction. Right. My topic right now covers shortest distance of approach. Shortest distance of approach. Now you are in a situation on a horizontal plane ground. You have a situation like this. Just this is east direction, this is a north direction. Right. I have an observer A moving in this direction with velocity VA bar. And I'm having another observer B who is moving with velocity VB bar like this. Now we will take this as origin. RA bar is position vector of A with respect to the standard origin. RB is position vector of B at some instant t is equal to 0. Right. Now you see the entire world, for example, in the reference frame of B. What happens? Now in the reference frame of B, you observe A, of course, with its natural velocity, it might have velocity like this. Number of possibilities are there. Just I'm showing one such possibility. One. So depending upon the magnitude of B, this is minus VB. Depending upon the magnitude of VB, three possibilities are there. One possibility is with respect to B, A may move like this. A may move like this. Remember, practically A is moving along eastwards. But with respect to B, A may move in this way. Another possibility is A may move like this also. The hitting B. This is also one possibility. I'll detailedly explain everything. Don't worry. Another possibility is also there. What is that? Another possibility is It may move like this also. Three different directions. See, remember all the three represents the three different directions of possible motion of A as observed by B, depending upon the magnitude of VB. See, in this case, you take three different lines I have shown. One case, A may pass through B. When is this possible? Simple. In all the cases, you are mentioning about this particular component called relative velocity of A with respect to B. Now I'll take up geometry like this. One geometry like this. Here is your A. Here is your O. Here is your B. Suppose if V relative of A with respect to B is in this direction. What is this direction? Don't forget, this is RB bar. And this is RA bar. Now, what about AB bar? Remember, AB bar is OA bar minus OB bar, which means RA bar minus RB bar. I repeat, there is no confusion here. I want you see the triangle. These two are taken in order and this is the reverse direction, which means RA bar plus, let us say this as R bar. This entire thing as R bar. R bar, RA bar plus R bar is the third side taken in reverse order. RB bar from triangle of vectors. So therefore, R bar can be written as RB bar minus RA bar. There are two vectors here. One is VAB bar, the other is R bar. If VAB bar is along R bar, then A collides B, undoubtedly. Why? Because the line of motion of A passing through B. Remember, all this is in the frame attached to B. So what is the condition for VAB bar along R bar? Simple. If VAB bar cross R bar magnitude wise is 0. When is that 0? When sin theta is 0. When is sin theta 0? When angle is 0. If this condition is satisfied, VAB bar is along R bar and A will collide B. That is one observation. Another observation. Here is your A. Here is your O. And here is your B. Unlike what I said earlier, if it is going like this, unlike what I said earlier, if it is going like this, line of direction of motion of A with respect to B, which means in this case, this is velocity of A with respect to B. And in this case, it is R bar. Remember, they are not in the same direction. They are not in the same direction. You can clearly observe that. You can see that there is some angle also, theta. There is some angle. In this case, if you draw a perpendicular onto this line, let it intercept at C. Remember, this distance is called closest distance of approach. Or shortest distance of separation. Remember, you are still in the frame of B. When B sees A will pass through a point C. That is the nearest point from B. Suppose in this case, you see, at an instant, A is here. This much distance of separation is there. At a distance, A is here. This much distance of separation is there. At an instant, A is here. This much distance of separation here. Actually, distance is reducing. Minimum. Then, again, distance of separation increases. Likewise. Likewise, you will notice. Okay. This is what you will notice. So therefore, the line BC is called closest distance of approach. Now, what I want is R cos, no, you want R sin theta, right? In this triangle, theta. Right. BC is, this is R sin theta. That is the shortest distance of separation. But vectorially, how to get R sin theta? Just now I have given. From cross product, I have given. If any time you want R sin theta component, like A sin theta, if you want, you do this. Same thing I am going to do right now. In this case, I want R sin theta. So what am I going to do? R sin theta is nothing but VAB bar cross R bar magnitude by VAB. If you do this, what you will get? Shortest, closest distance of approach or shortest distance of separation is what you will get. Not only that, you see in this is R cos theta. And your velocity along AC is V relative. So time taken also you can calculate. Time taken to reach that is nothing but AC by VAB relative velocity magnitude. AC is nothing but R cos theta by magnitude of VAB. Or dot product I have given. If you want R cos theta, dot product, just now I taught you, just now. If you want R cos theta, what you will write? Component of B along A, R cos theta is what you want. You will write it as A bar dot B bar by A. Same thing I am going to use here. I want R cos theta here. R cos theta. So R cos theta is nothing but VAB modulus of dot R bar by magnitude of VAB AB, already 1 is there, so square. Because you can write r cos theta as magnitude of VAB bar dot R bar by magnitude of VAB. Right. That's all. Only two cases you are supposed to know. Just confirm whether you followed this or not. Someone please use the communication channel to confirm me, have you followed this? First condition, A collides B. Second condition, A narrowly misses B, means it passed through a point C, which is considered to be the shortest distance of separation or closest distance of approach. Someone please confirm. Yes, sir, understood. Thank you. This is one of the important models in relative motion. Lot of students fail in solving these questions. You can use this for any model. Like for example, I'll try to give you a model like this. Now you are seeing a situation. It was given that an object which is traveling with a velocity 10 meter per second makes an angle 53 degrees with x-axis. Let this be origin and this is at 100 meters. Right. Another one which is traveling with 5 meter per second makes an angle 37 degrees with x-axis. Let this be A and let this be B. Will they collide? First question. If not, what is the least distance of separation? That is the question. Two ways you can solve this question. One, the methodology which I have provided to you. Two, do the entire problem in the reference frame of B. Now, first try to draw the components properly. What are the components of A? Now, this is a given question. That is a given question, and I am modifying that question now. Modifying in the sense, redrawing the given conditions properly. Now, what is the component of B in the x direction? 5 cos 37. 5 cos 37 is nothing but 4. And 5 cos 37 is 5 sin 37 is nothing but 3. These are the component of velocities of B. This is of B. What about A? A component is 53. 10 cos 53. 6 meters per second. Whereas the other one is 8 meter per second. That's what I observe. Okay. This is the first diagram drawn from the question. Now you draw everything in terminology of B. You draw everything in the terminology of B. Now I am in the frame of B. What I will observe for A? A will have one velocity. What is that? 6 minus 4, because both are in the same direction. 6 minus 4, 2 meter per second. The other one, 8 minus 3, 5 meter per second. Undoubtedly, A will not collide B. Why? Because this is the direction of motion of A. This is direction of motion of A as observed by B. Then what is the other option? You draw a projection from B onto this line. What is this line called? Shortest distance of approach, or shortest distance of separation. Clearly, you know this angle phi. Yeah, I know the angle phi. Why? Because I know these components. Tan phi is clearly phi by 2. Right. You know AB. Let this be C. You want actually BC. So BC by AB is sin phi. Remember, if you know tan phi, you can find anything. You have phi. This is phi. This is 2. This is root 29. Because phi square plus 4 square under root. You want sin phi. Sin phi is nothing but phi by root 29. Also, we know AB. They are separated initially by 100 meters. They are separated by 100 meters initially. So, therefore, boys, you will have BC is equal to AB into phi by root 29. 100 into phi by root 29. That's your answer. Okay. This is without following any of those vector mechanisms to solve this question. First, this is the given data. This is the given data. Next, this is the modified data resolving into components. Next, studying everything in terminology of B. Okay. This is one method of solving the same question. The other method, now first, what is V related to? What is V related to? For this purpose, you need to write VA bar properly. VA bar is 10 cos 53 I cap plus 10 sin 53 j cap. This can be written as 6 I cap plus 8 j cap. Right. VB bar. VB bar can be written as 5 cos 37 I cap and 5 sin 37 j cap. This can be written as 4 I cap plus 3 j cap. First, velocity of A with respect to B is what you want, which is nothing but VA bar minus VB bar. This is nothing but 6 minus 4, 2 I cap, here 6, right, 53, 37, right, plus 8 minus 3, 5 J cap, right. I got VAB. Remember, this is R bar. That is R bar. R bar already, you know, with respect to that. So, R bar means, sorry, direction wrong I mentioned. You draw a line from A to B, that gives R bar. Clearly, R bar is 100 I cap. Right. So, my vector data is confirmed. What do you want? Formula for shortest distance. What is the formula for shortest distance? This one. VAB bar. Now, we need to do this part. Right. I need some space here. Right. I'll change the color to avoid this. See, VAB bar cross R bar is 2i cap plus 5j cap cross 100 I cap. This you can write as 2 into 100. 200 I cap plus I cap plus 5 into 100 j cap cross I cap. Arey, you want only magnitude of this, don't forget. I cap cross I cap 0. 0. And 500 j cap cross I cap minus k cap. So you will get magnitude of this nearly as 500. Non-zero. Non-zero means they won't collide. What is the condition for collision? This must be 0. This is not 0 now. So no collision. Nothing is happening here. No collision is taking place. I'll stop after this. Don't worry. I think someone was really worried for the break. Right. Then more point is magnitude of VAB. What is the magnitude of VAB here? Magnitude of VAB is under root 4 plus 25, root 29. So clearly, what is your answer for in vector form? Shortest distance. Shortest distance in vector form. VAB bar cross R bar divided by magnitude of VAB bar. And this comes as 500 by magnitude of that root 29. That's what I got. In fact, you see, 500 by root 29. Okay. Now, someone please confirm whether you followed this technique or not. Someone please confirm this. Someone please confirm. Right. So this is the part of the data which I would like to discuss it for today. Hold on. Right. Right. Yes, sir. Understood. Got it, sir. Yes, sir. Thank you. Someone lowered hand. It's not me. Right. Fine. So rest of the lesson we will deal it in our next class. Now today I have done some basic part for vectors and I have introduced relative motion. Tomorrow I will deal completely riverboat problems. They are very difficult questions actually. We will inform you whether it see for 2 days, tomorrow and day after tomorrow, let us have online classes because intermediate supplementary exams are happening over here in the same building. We might find some big difficult problem in handling that. So therefore, we are planning to conduct the classes online method. Okay, chalo. They will inform you.